This is the last question on June 2021 paper. The question says, this question is about acids. So remind yourself, when it comes to acids, it could be about why a given acid is a strong acid or a weak acid. It could be about determining the reactivity of different metals with respect to their reactions with acids, or it could be about neutralization reaction. Here it says hydrogen chloride and ethanoic acid both dissolve in water. This means when they are added to water, they will dissolve and they will form a solution. All hydrogen chloride molecules ionize in water. What does this mean? They will ionize in water means they will change into H plus and Cl1 minus. The question further says approximately 1% of ethanoic acid molecules ionize in water. In this case, I can say H positive is going to be very, very low. Based on this data, I can say this means it is a weak acid. And this one is strong acid. Now the question says a solution is made by dissolving 1 gram of hydrogen chloride in 1 dm cube of water. 1 dm cube is same as 1 liter, which is correct description of this solution. So you've added strong acid, so it will be a solution of strong acid, but it will have a different concentration. Here it says a concentrated solution. Concentrated solution is one in which a lot of acid is present. But in this case, we've only used a small amount of acid, so it's not going to be concentrated solution of strong acid. So this is wrong, this is right. It says concentrated solution of weak acid. In this case, this is wrong and this is wrong as well. For the next option, it says dilute solution. Dilute solution is one in which there will be less amount of acid. So this is correct. And it says a strong acid because we've used hydrogen chloride. Therefore, it is a strong acid. And the answer is this. The next part says which solution would have lowest pH. Lowest pH means it is the strongest acid. So we've got 0.1 mole dm cube ethanoic acid. This is weak. Here we've got strong acid, but now the concentration is low for both of them. If you look at the next two options, they are both high, but here it is ethanoic acid, which is weak. Here it is hydrogen chloride, which is strong. So the answer will be this. The question then continues, and now the student decides to carry out a titration. So they've given us some data about it. It says a student investigated the concentration of a solution of sodium hydroxide by titration with 0.0480 mole per dm cube ethanoic acid. Again, important to understand. So what they're trying to do is they're trying to work out the concentration of sodium hydroxide. This is not known, but we can determine it using titration. This is the method the student used. Number one, measure 25 centimeter cube of sodium hydroxide solution in a conical flask using 25 centimeter cube pipette. So they use pipette to transfer 25 centimeter cube of sodium hydroxide in a conical flask. Then they added 2 drops of indicator to this sodium hydroxide solution. Once you've done that, now you are going to fill the burette with this acid to 0 mark. Once you've done that, then you add ethanoic acid to sodium hydroxide solution until the indicator changes color. So when the indicator changes color, you'll stop. You'll record the volume of acid used. Then it says read the burette to find the volume of ethanoic acid solution used. Now this is the general method that we use when we are performing titration, but there are some improvements that can be made to this method so that we can end up with a more accurate result. And that's what the question says. It says suggest 2 improvements to the method that would increase the accuracy of the results. While I was reading this question, I was thinking in my mind, and I see I can make 3 types of improvements at this location. So where it says add ethanoic acid to the solution, it doesn't tell us how. Do we just have to keep on adding, or do we have to add it slowly? So the first improvement that I can suggest here is I have to add it dropwise so that the end point is accurate. That's improvement number 1. For the second improvement, what we are trying to do here is we are trying to observe when the color change takes place. So it is better if you use a white tile. under the conical flask, it will make it easier to observe the color change taking place. The third improvement that I can think of here is because it doesn't say what will you do to the solution that's in the conical flask. So you have to make sure while you're adding solution from the burette, which is acid, to the conical flask, you have to make sure you are swirling the conical flask. Based on this entire method, I've identified one more improvement, and that is you don't do the experiment just once. You have to make sure you do it number of times and then you calculate the average. So that's what we are going to list down as our improvements. It's a 2-marker question. I only need to provide 2. But because I'm going through these questions with you to improve your learning, I'll list down all 4 of them and then you can choose the ones that you want to keep in mind. So we can say number 1, swirl the mixture while acid is being added. Number 2, I can say repeat experiment, let's say 3 times, and calculate average. Number 3, I can say add acid dropwise. Number 4, place white tile under conical flask. Now, I do want to remind you that this question is very important because who knows, it might appear in your exam as a 6-marker. So you'll have to write down the method of performing titration. If they ask you that question, this is what you will have to write down in response to that question. The next part says ethanoic acid is a solid at room temperature. Calculate the mass of ethanoic acid, which is H2C2O4, needed to make 250 centimeter cube of a solution with concentration of 0.0480 mole per dm cube. And they've given us the relative formula mass for ethanoic acid. So in this case, we've been given concentration, we've been given volume, and we've been asked to find the mass. Now, we can't work out mass directly from concentration and volume, but we know if you are given the concentration and volume, you can convert that into moles using expression, which is mole equals C times V over 1,000. Remind yourself, this volume has to be in centimeter cube. This concentration has to be in mole per dm cube. Now, all you have to do is you just plug in the numbers and then you solve and you'll end up with the value of moles. So I can say moles will be equal to concentration is 0.0480, volume is 250 over 1,000. If you plug these numbers in your calculator and you solve, you'll end up with a value of 0.012 moles. So that's step 1. Now for step 2, I can convert moles into mass. So I can do moles equals mass over mr. And in this expression, I know the value of moles, which is 0.012 equals mass is not known. I'll keep it as mass. mr is given to us as 90. Put 1 in the denominator on the left side, cross multiply, and you will end up with the value of mass being equal to 1.08 grams. Now there is another method of solving this question, so I'll discuss that quickly as well. We know this expression that mole equals C times V over 1,000. Now I do know at the same time mole also has this expression, which is mass over mr. So before I plug in values in this expression, what I can do is I can replace the left side by mass over mr equals C times V over 1,000. Now all you need to do is you just have to plug in the values and solve, and you'll end up with your answer. For example, here I do not know the value of mass, so I'll keep it as mass. mr is 90, C is 0.0480, times by volume, which is 250 divided by 1000. Now, if you solve this, again, what you can do is you've got single fraction on both sides. You can cross multiply. And if you solve it, you will still end up with the value of mass being equal to 1.08 grams. The last part of this question says the student found that 25 centimeter cube of sodium hydroxide solution was neutralized by 15 centimeter cube of 0.0480 mole per dm cube ethanoic acid solution. Now this statement is very important, because I can use this statement and I can divide it into two sections. I can say this side is for acid and this side is for alkali. And I'm going to write down their data. So for the acid, I'm given 15 centimeter cube of this mole ethanoic acid. So I can say volume is given to me as 15 centimeter cube. And the concentration is given to me as 0.0480. For the volume of alkali, I'm given volume as 25 centimeter cube. Now, once I see that I know the volume and concentration, I can use moles equals C times V over 1000 formula, and I can find the moles of acid from here. So I can say here the concentration is 0.0480. The volume was 15 over 1000. These are my moles of acid. And if you plug it in your calculator, you'll end up with a value of 0.00072 moles. These are for the acid. So that's my step 1. For titration questions, when you have to determine the concentration of the missing solution, this will always be your step 1. You'll convert the concentration and volume for a given substance into moles. Step 2 will be using equation. So you will use equation to determine the moles of alkali in 25 centimeter cube. I can see here the mole ratio is 1 to 2. This means 1 mole reacts with 2 moles of alkali. So I can say here moles will be equal to 2 times 0.00072, and if I multiply that, I will end up with 0.000144 moles. Now you have to remember these are in 25 centimeter cube. I can again make use of the same equation that I used in the first step, in step 3, to work out the concentration of alkali. I'll use moles equals C times V over 1000. I just calculated my moles in step 2, which is 0.00144. Concentration is not known. The volume was 25 over 1000. You can put 1 in the denominator and you can cross multiply. If you cross multiply and solve, you'll end up with 1.44 equals C times 25. We divide both sides by 25. This is cancelled out. And if you plug this in your calculator, you'll end up with 0.0576 mole per dm cube. And this is my concentration of alkali. Fairly easy question. You just have to remember the steps. Step 1 is always convert given volume and concentration into moles. Step 2 is always using equation. This is from step 2. And then step 3 is always using the same equation, which is moles equals C times V over 1000, to find the missing concentration.